hey, thanks for reaching out with this question. This is a really great question because often students come away from general chemistry not being able to do this sorts of things. But if you end up in a lab in the future as a technician, as an assistant, or maybe in grad school, like this is the sort of stuff that you need to know how to do. So let me try to translate this question a little bit, and that'll make a little bit more sense for you and what the answer is. So in this scenario, you have cells that you're growing. Maybe they're on a plate, who knows, but you're growing up your cells. And each one of your little cell wells is going to have 2 mils of media along with your cells so that they can grow up nice and big and happy, or maybe not nice and big and happy, depending on what your drug does. So you have the 2 mils of media, okay? Importantly, in this media is not just the drug, right? So we have the drug, but also like buffers and food, nutrients, right? So we just want to be able to add a little bit of our stock of drug to this media so that the cells can use it, okay? So your teacher said, how about if we add 20 microliters of drug to our media, right? Okay, so what concentration does this 20 microliters need to have? Okay, our final concentration, after we add to the 2 mils, final concentration will be 30 micromolar. So what is our initial concentration? Well, this is just M1V1 equals M2V2. Okay, so our initial concentration, that's what we want to know. Our initial volume is 20 microliters. Our final volume is 2,000 microliters. And our final concentration is this 30 micromolar. Okay, so M1, we can do some algebra here, equals M2V2 over V1. That's going to be 30 micromolar times 2,000 microliters divided by 20 microliters. So this is where your teacher is getting the 30 times 100, right? Because this cancels out to just be 30 times 100. So this is 3,000 micromolar or 3 millimolar. Okay? So the stock of drug that we want is 3 millimolar. So at the end of the day, we can just take 20 micromolars of this and add it to our cells. Okay? So how are we going to make a 3 millimolar stock when we only have 1 milligram? So this is where like your teacher kind of lost me, because I think there are some better ways to do this. And what we're going to do is, okay, so now the new question is what volume to add to 1 milligram to get 3 millimolar? Okay? So what I would actually suggest is to use dimensional analysis to convert from milligrams to milliliters using your concentration as a conversion ratio. Okay? So let's take a look here. We've got 1 milligram, and we're just going to convert to millimoles. Okay, so it's the same idea as grams to moles using the molecular weight. Same number, right? Because you have this many milligrams per millimoles, you do grams per mole. Okay? So now our concentration is millimoles per liter. Okay? So we're going to put this 3 millimoles per liter, and then we want to convert that to milliliters. Okay, so 1,000 milliliters per liter. So if you do that through, I'm going to do this on my phone real quick. 1 divided by 273.47 divided by 3 times 1,000. You can do it on your own time. That gives you 1.219 milliliters. Okay? So you're going to take I'm running out of space here, but you're going to take your stock of 1 milligram, and to that you are going to add 1.219 milliliters of water or whatever your solvent is, that will be your stock of 3 millimolar, and then that's what you're going to take 20 microliters of and put in your 2 mils that your cells are going to use. I hope that makes a little bit of sense, at least a little bit more sense than your teacher did. But again, I'm really happy that you asked this question, because this is the sort of thing that technicians and researchers need to be able to do, but they don't get practice with it in general chemistry. So I'm really happy that you had practice with this. Hopefully this makes sense to you.